All right, so we're doing more chain rule problems, this time with logs and exponentials. We'll do the exponentials first, starting with this one here. So the thing to be careful about when you're dealing with exponentials is, remember, the exponent only applies to the thing that is directly next to it, unless there's a parentheses like this. Unless there was a parentheses like this. Okay, so the 2x minus 4 does not apply to the 3. The 3 is just a constant. And when you take the derivative of something with a constant, you just multiply the derivative by the constant. So we'll just leave that 3 there and then ignore it for now, okay? And then we'll worry about differentiating e to the 2x minus 4, okay? The derivative of e to the x is e to the x. So that means that when we're doing it with the chain rule, we just leave the argument the same, or we leave the term basically exactly the same, and then just multiply by the derivative of the argument. The argument's 2x minus 4. Its derivative is 2. So we multiply by 2. Once we consolidate our constants there, 3 and 2, we get 6e to the 2x minus 4. And that is it. All right, let's go to the next one. Here we do not have a constant, so we don't have to worry about that. But we do have a little more complicated term. However, remember, the argument stays exactly the same, and the term stays exactly the same as well when we're dealing with e. So we have this, and then we multiply by the derivative of the argument, which in this case is going to be 2x minus 9x squared. Okay, and that's your answer there. All right, dealing with e to the x makes it usually pretty easy to do these problems, right? Now here we have a 2 in the base instead of an e. So you have to remember that the derivative of a number to the x includes the natural log of that number. So this is going to be similar to the e to the x problems, but we're going to put an ln2 in front, then the term exactly as it is in the problem, and then the derivative of the argument. Okay, so the argument is negative x to the 4th. When we use the power rule on that, we get negative 4x to the 3rd. Okay, you can basically leave it like this, or you could, do negative 4x, or yeah, negative 4x to the 3rd times ln2 times or over 2 to the x to the 4th, because of the negative exponent. Something like this could be a nice, neat way to write it. Okay. Next problem. Now we're moving to logs. Okay, the derivative of natural log of x is 1 over x. Okay, so we're going to be using that property here. We're going to be doing 1 over whatever's inside the argument. Okay, so it's 1 over 1 minus 6x. And then we're going to be multiplying by the derivative of the argument. The derivative of this is negative 6. So we multiply this by negative 6. And you can consolidate it in a nice way by just writing it as a single fraction. Negative 6 over 1 minus 6x. All right, now the next one, same thing. 1 over the argument times the derivative of the argument. The derivative of this is 6x squared. Can't leave it, or not, you can't, but you don't leave it like this, because you can do a bunch of canceling here, right? We've got an x squared with an x cubed, so that leaves a single x to the 1st on the bottom. We've got a 6 with a 2, so that leaves us with a 3 up here. So what we end up with is 3 over x, which makes sense if you think about the fact that you can decompose this into 3 natural log of x plus natural log of 2. All right, so for the next one, and I guess the last one, we have to remember that when we are using a log that is not a natural log, that we have to incorporate a natural log of the base of the log. Okay, the base, when we do not write the base in logarithms, is 10, right? We use the standard that if we just write log x with no base, then that means log base 10. Okay. So how do we incorporate the natural log? We write 1 over natural log of 10. Okay, so whenever we're differentiating logs, we're going to, with a non-e base, okay, we're going to write 1 over natural log of the base number first. Okay, and hopefully that explanation was not as mangled as it sounds like it was. All right, anywho, now we do the same thing we do with natural log. It's 1 over the argument times the derivative of the argument. Okay, derivative of this is 3 plus 2x. Okay, so we can write that in a nice consolidated form as 3 plus 2x over natural log of 10 times 3x plus x squared. All right, and that is that.